So I never actually go anywhere, I'm still here. So here we go. We're going to find the equation to the tangent line to the curve at a given point. So we're going to have y prime. So we need the slope because we need two things, slope and a point. So we're going to find the slope. And what that's going to require is the quotient rule. So we're going to take the derivative of the numerator, and we're going to have negative sine x. And then we're just going to keep the denominator the same, 2 plus sine x. Quotient rule says we need a subtraction there. We're going to take the numerator, and then we're going to multiply by the denominator, derivative of the denominator, excuse me. And of course, you probably already caught that. I need the derivative of the denominator, so that 2 is a constant, and it's going to be a gallon. So I'm going to get rid of it here, and bam, bam. All right, so I'm back. All right. So now, eraser, here we go. Nope, I need my pen back. It is late, guys. This has been quite the week. All right, so now I'm going to take the derivative of the denominator, which is just going to be cosine x, and I'm going to divide that by the denominator squared. Okay, and then we have our point here. And that point is going to be x equaling 0, and so we know that y is going to be cosine 0. Cosine 0 is 1, and that's going to be 2 plus sine 0, but sine 0 is 0, so we get a half. So our point is 0, 1/2. And so over here, we still need our slope at x being 0, so I'm going to plug that in right now. I'm not going to simplify this. I don't really see a point if I'm just going to plug in 0. Why do anything? I'm just going to plug in 0. So what we see is that's going to be a negative 0 times 2 plus 0. Well, that's exciting. Minus, and then cosine 0 is 1, and another cosine 0, so we basically have 1 squared. And then I'm going to divide that in my denominator here. I'm going to have 2 plus, and then sine 0 is 0. So it's going to look like this. And then as I just simplify this, I'm going to end up with a negative 1/4. So there's my slope. So now I have my slope and my point, and well, that's exciting. So now I'm ready for my equation. And so we're going to have y minus 1/2. And then my slope, which is the negative 1/4. See, this one's a lot nicer than the last one. We don't have the pi's. X minus 0. And we can see that just with a little bit of simplification, we get our slope. I'm going to bring that 1/2 over. When I do this, I'm going to end up with 0 there. So I'm just going to have a plus 1/2. And so there's the equation of that tangent line. And you can graph that, always feel free. Go to Desmos, graph the function here, graph the tangent line. You should see that this tangent line is tangent to this curve at this point, just to kind of cement that for yourself. Now, we just have a little bit more. And when we're doing this part, it's going to be pretty exciting because we're going to use that limit that we just found in the beginning of today. So don't forget that we found earlier today, I hope you remember, the limit as theta goes to 0 of sine theta over theta, we already learned was 1. So I'm going to use that in a problem like this. If you see anything like this, this is what you need to use. So the idea here is we want to make what we have here, this sine of 5x over x, look like this. The key thing being that you have a theta here, you have a theta here. More importantly, you just have the same thing. So you need the same thing here, but you don't have it. So in order to use that limit from beginning of today, we have to have a 5x. So notice I basically just put a 5x in my denominator. I basically just multiplied this thing by 1/5. So in order to balance it, I then have to multiply by 5 over 1. So understand that the idea there is that this 5 simplifies with this 5 so that it's still what we have. So it's still that idea of multiplying by 1, that math thing that we do all the time. But what it means is that we can pretty easily now just move that 5 to the outside of the limit because it's just a constant. And then we have the limit as x goes to 0 of sine of 5x over x, 5x, excuse me, because we put that in. And the idea here is this piece is going to be 1, but we just need to do a little bit more work to make that happen, because see, it doesn't look like this theta, you know, the theta over theta that we have over here. So what I'm going to do is just, I'll use theta right now, this idea of theta, I'll call theta being 5x. And the reason I'm doing that is I'm basically using substitution. So I can say as x goes to 0, so basically if we were to take a limit of 5x, as x goes to 0, you know, 5x is going to go to 0. So then that tells us that theta goes to 0 as well. And the idea behind that is that by doing so, we can now make this into the idea of the limit as x goes to 0 of sine of theta over theta. So that's because I did this. And again, as x goes to 0, theta goes to 0. So that tells us that we can look at it this way, and the answer to that we already know is 1. So that tells us that our limit here is, in fact, 5. So down here, it's going to be something a little bit similar, but as you notice, that it's not exactly the same. So I'm going to separate these into 2 different limits. And I'm going to have sine of 4x, like this, and I'm going to have sine of 6x over here. And then the idea is kind of like, okay, well, what do we need to add so that these would look kind of maybe like limits we can take? And so I'll do this in like a different color here to show it, but we need a 4x here, and you would probably recognize that just because of what we did above, but we actually need a 6x up here. And that's like kind of the idea of like the reciprocal idea that we can look at in terms of finding the limit there. But of course what we just did was the x's simplify still, but we multiplied this thing by 6 over 4. So we just need to multiply by 4 over 6 so that, you know, when you look at everything that I have in red, if you were to multiply it out, you're still just going to get 1. And that's of course the key thing with these problems, is that you just kind of keep multiplying by 1. So I'll come back to my normal pen color here and put it back to being the blue, just to not be too scary. So this is going to give us the limit as x goes to 0. And really it's just separating each thing into its own piece. So we have sine of 4x over 4x, and then we have, you know, the limit as x goes to 0 of 6x over sine of 6x. And then really, you know, what I should have done is bring that limit of 4 over x out to the front, because there's no reason to not do that, right? Because it's just a constant, so it's not being affected by the limit. So I'm just going to put it out in the front. So you can do that as well, or you can write another line. It is up to you. So now, there we go. I'm going to come over here, and I'll put my 4 over 6. Okay, and don't ask me about that extra line. Not sure what I did there, but I'll get rid of it. This is really exciting, everybody. I'm sure you're all enthralled. Okay, so now, okay, come back to my pen. Ta-da. All right, so now we're actually going to do kind of these similar ideas. So we'll have, like, you can do the same type of thing for this piece that we did up here. But we also need to consider this piece. As you can see, this is a little bit different, a little bit weird, but we're going to let, what I'll do is I'll I'll let, say, v equal 6x. And then the same thing, you know, as x goes to 0, we get that v goes to 0. And that tells us something about, you know, what we have here. So what that's going to give us is essentially we get 4 over 6. We get the limit as, and so again, like I can do the whole thing, like theta equals, you know, okay. Okay, whatever. So that's basically gone. Okay, so let me come back to my pen. There we go. So I can let theta be 4x, and then, you know, same thing, as x goes to 0, theta goes to 0. So what I did make a small mistake on that I just realized up here is that I should have called this theta. This should not be x because I changed it to theta. So I just realized that I did that. So just make that small change there, and then I'll be back to the pen and theta. All right, so now I have what you see here, down here. And so now I'll change this. So as theta goes to 0, yowza, and then that's going to be sine of theta over theta. Now over here, I'm going to have the limit, and again, I'm changing this. I can't call it x because I'm like making a substitution. So I'm going to say as v goes to 0, I promise we are almost done here. So what we have here now is v over the sine of v. Now, I really want to start taking limits here, but as we know, a little bit of a challenge. So I have 4, 6. I have the limit of this piece. We've already talked about that 1. But over here, I have the limit as v goes to 0, but I have v over sine v. So this is where it gets kind of a little bit tricky. But what it is we can divide top and bottom by v. And then that's going to give us v over v, and then sine v over v. And you should notice that's what we want. I mean, that's the thing that's 1. So now we're looking at this as 4 6 and then times 1, but we already have that. 1, the same thing is my point, 4 6. V goes to 0, and then we get 1 over, and then the sine v over v. Okay, but we know that the limit as v goes to 0, sine v over v is 1. So we can now just have 4 6 times 1, and that gives us 4 6. So yes, a whole lot of work for just the fact that our limit is simply 2/3. But that is the reason that it is that, and that's why we get that. So that is it. So that is section 2.4. Good luck, everybody.